Welcome to a new video on my Raspberry Pi 1 running Raspberry and Linux, equipped with Raspberry Pi camera, RaspberryCam, supported by a stand with fischertechnik, made with fischertechnik, a serial cable connection to laptop for data acquisition, also a probe to get on the oscilloscope a signal from the same serial connection. Somewhat hidden right here, network cable for VNC, virtual network computing, and of course a band cable that goes right here to this part of the circuit with an MCP 3008 analog to digital converter, because the Raspberry Pi can only work with digital signals. So this fischertechnik light dependent resistor, a normal LDR light dependent resistor, and a negative to temperature coefficient resistor are connected to it through the SPI protocol serial peripheral interface. Also, last time I reintroduced two LEDs which will blink when the value of the LDR is beyond a certain value. And then also this Android tablet in which I started the Pi scope, which is also running on the VNC, as you can see. And last time it showed that when I go closer to the camera, then or closer with the camera, then you can see anything. So that may be a nice thing. Also, oscilloscope which shows SPI signals, as in data, master input, master output, and RS232. And further away is a Mac, which I can also show some nice stuff. Anyway, right now, continuing where I left off last time, which is the strange thing that I can only grab one LDR and the rest isn't logged in the data file. So let's go to the software side and see whatever is happening or not. Alright, software side, camera, and I can point it, of course, to the various things. And oh, by the way, this red LED you see right here is this one, the Raspberry Pi camera. No software running, so let's do that first. Data log, maincom connection, and the virtual network computing with another instance of the Pi scope. Software side, where I send everything over serial port as well as write it to datalog on here as well. Anyway, let's start the software. That's the nicest to do. There things go. Also, what I was talking about is of course Octave, which is supposed to read and then detect either LDR, LDR2 or NTC, where everything is then put into a data log. And of course it is eminent that you send the right stuff over. And here you can see that the Raspberry Pi 1 is a slow board. Because what are you sending over? Well, LDR, LDR2 and NTC. That is very clear. So that is also being done here. Now the point is, I have to quit this nice stuff, otherwise my input to Octave will be absolutely garbled. And what I do not see happen, oh now I see happen, TX. So it's data, chip select, and master input, slave output, and master output, slave input. So let's run this and then try to figure out why last time, because that is another thing, why only LDR1 is being done. And then another thing, last time I also found out that this value is actually absolutely correct, but, and that is a very important part, why is this in byte value and not in ASCII? Because it turns out that this is the, when I convert it to ASCII, I get a nice number like I'm getting in here. So if I put LDR231, then in bytes it is this value. So that is a strange thing. And here I put everything nice, here too, and yet it prints it different. So why does it do that? Doesn't make any sense. Let's run it. Press F5. Oh, right. Once again. No, not here. This one. I have to change ownership. Claim ownership of the serial cable. Otherwise it won't run. Now it can. So let's put it here. And see what difference it makes. Uncovering the other one, covering the other one, I should say. Not much happening, I'm afraid. But it doesn't really matter. It is about values being detected. Now I've also learned that I have to quit this algorithm to check on the data log files. So let's do that. And minus L to see the date, which is today, so that is good. Oh, now see, now it has LDR2 as well. That is a nice change, but still no good values. So that's the next thing to do, how to get the values in. Some observations. First of all, only LDR and LDR2 are being logged, while from the command window the data absolutely says, okay, this is NTC. So why is NTC not in the data log? Then going here, the values of LDR and NTC are clearly 3 figures. You can also see that right here. Well, NTC is maybe 1, but these are all 3 figures. So going back here, why did I make this? This should be 4, 4 and 4 and 4. Apart from that, this one is clear. I also want to make clear or sure that I know which value is printed here, so I made an equal sign here. And for the rest, I have no idea why these values are not ASCII. If I print data 2, which is printed right, data 2 is primarily used there, so I may just as well say, alright, I want to print data 2, so disk data 2 is, and then say data 2 transpose, and flush out, of course. STD out. Alright, that's better. Okay, now let's run again and see whatever happens. Okay, this is not exactly what I meant. Data 2 just printed, and then we get here. Okay, so I wait, I quit, and I remove this one. So this should be better. Let's see. Yep. Except that I need to have a lot more values. And I have to be patient. Okay, wait, let's look at these values as well. So once more, what do I get? See, those are nice values. Very nice values even. But are they recorded? Now I can see data 2 and I have to be very patient to record anything of NTC or whatever. It does occur, and when I look at the oscilloscope, which I have to show as well, so these should be nice values. Let me also show you the oscilloscope then, right there. And once again you see the serial line giving nice data, lowest line, but barely anything on the SPI lines, which is strange. Which is very strange. And here another pi scope, which is not surprising the same as with the other one, although it is not exactly the same. There is some delay. Probably because of the wireless. Anyway. Let's check the value so far. And for that I have to interrupt this one. Go to the data log. Regard the time. Okay, 10:09. That's good, I think. But what does it show? That's not good. This is not good. Why do I get nice values here, but not here? Still doesn't make sense. I don't like that. So somehow this does work, because I get a fairly normal output from this one, data 2, but the others don't do anything. LDR2. Says nothing. LDR2. Wait, where's LDR2 anyway? LDR. I do need to see. Well, LDR1 is. That's what I need to see. Now that is curious. I see a lot of data too. Okay, here NTC value. That's good. Here I see LDR1 is. That's good. LDR2 is 13. So when I compare that, that's rubbish here. And I know that this is the delimiter. So I have to look at the first three values, and that's not making any sense. Like 231, there's nowhere, and yet it is printed right here. So why is that happening? What's wrong? So I have changed the algorithm a bit, in the sense that I have now added the resistor as well. I have removed again data 2, since it is printed anyway. So now the question is, what is being done exactly? And here it shows, I've been running it for a bit now, that it is quite hard to see anything. This is NTC obviously with number 3. This is 2 and 1. And 1 again. This is a 4. So I have to stop it to look at the data log. But there are just a very few values that are selected, of course. So let's stop it and look at it. And then of course I have to see if, okay, look at this. This is the same timing. What does it do? Go to the end. And now the best thing is, of course, going all the way up. Yeah. Does it see an NTC? No. Does it see a resistor? No. So this is very strange. And apart from that, of course, still the wrong values. What happens if I don't do it like this? So, just a very short test, and like this. What happens, if anything? A failure or whatever. Go. And now I have to wait for things to be equal, which seems to be here. And if this would help, it will be very strange. But I have to wait for some more input. And here it is a constant go. So let me influence it once more. And I have to keep in mind that this one doesn't make contact with other stuff. This is the normal LDR. So, waiting for some nice values. And that seems to take time. There we go again. Weak material. Okay, that's enough, I hope. Is it enough? Yeah, I had here a 3 as well. 1 and a 4. Okay. So this should have been written to the log file now. But is it? This would be 59, that's good. lo and behold, look at that. Look at that. Okay, so that would mean that I'm going to change this into this one. Same goes for this one. If that is indeed the whole trick and nothing but the trick. No. Go. And this one. Right. Let's see if this works out. If. This is NTC anyway, this is LDR1 anyway. This is LDR1 again, the NTC. I don't care for anything for any else. I have now some results. They could be nice. Okay, here again, what is this? Oh, resistor, nice. And LDR2, alright, very nice. So, I am assuming they are written to the data file now. Or am I making a mistake? A big mistake? Oh, wait a second. I am making a big mistake. This is supposed to be 3. This is supposed to be 4. So yes, I am making a big mistake. That is why things don't occur in the data file. Yeah, that makes a difference. So I have to do it again. And here it goes for equal 3. Wait a bit, and this takes time. I'm going over half an hour of data or video. This is LDR1, this is NTC. But at least probably now they will be recorded as NTC and resistor and etc. Okay, what is this? LDR1 and NTC. Alright, so time to look at the data log. That is 10:03. Okay, I'm fine. Oh, look at this. Is this correct anyway? No, it is not. These are not correct, because I recall these as ASCII values. ASCII values they are. No, they are not ASCII values. In no way. So it's still not saved. Still not alright. This was a mistake, but this doesn't solve it. Nope. Need to think again. So that is resistor. And right. So what next? What brilliant idea next? Alright, and just a little watch on the Mac. Good view on the LDR from fischertechnik. Bit hidden is the LDR from just an LDR, standard one. Pi scope, which is kind of responding slowly, but now I have 3 instances of Pi scope running, all via VNC of course, but now one displaying on my laptop, one displaying on my Android tablet, and one displaying on the Mac. So and with an old Raspberry Pi as mine, 1B plus, yeah, it slows down. Whether this is slowing down the whole thing, I don't know actually, because this is just one stream and it is being streamed on my laptop, to my laptop, and to the Mac right now. It's one stream, so that won't slow down. Anything else I do not really know. I also have to check out on the data log, but I don't care right now. So let me grab a final look at the data log from Octave, and that will have to be it. The oscilloscope, by the way, shows a very nice regular pattern on the serial line, but hardly anything nice on the SPI, which I'm surprised of. But maybe the time base is way too low. But I can't really explain that. Although I've gone to microseconds now, and then I do see something, so that... Alright, last things from here. Running this one still, so interrupting to see the data log now, and that is going to be a quickie. Yeah, time is correct. And look at this. Well, this is obviously very wrong, but at least I have them all. Resistor, NTC, I have them all, thanks to a change in this one that I actually display everything. So at least that's correct. How to change the data into ASCII? That is unfortunately a very different question. And by the way, this is the same VLC stuff. So where does it lead me? Well, again, big question. Can it handle it? I have no idea. We'll see next time. Because there will be next time. Oh, and I should show you the oscilloscope again. So now time setting is, let me show you nicely. Time setting is now 200 milliseconds. Blue line. And oh wait, it would be nicer if I of course record everything, but it's still sending. And if you look close enough, I hope you can see the SPI going there with blips and peaks as well. But that takes a very close look, as does this. And that is really it for now. So yeah, and that is it for now. So results are not completely what I expected, but at least I did fix some errors. If you like this video, please subscribe to my channel, give the video a thumbs up and leave a comment or suggestion. You can also follow me via Instagram and Twitter. Please show your appreciation by making a donation via either PayPal or Wired, IBAN in Europe, IBAN account. And you can also show your support by becoming a patron and have your name, and you may have your name mentioned depending on the pledge you make. More information please see under this video. To be continued. Have a nice day and bye bye.